Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Okay, welcome back again to my channel. Okay, so this time we are going to look at exercise number 2. Okay, so if you missed the previous video, so please check the link in the description down below. Okay, so let's look at this question. A multi-layered wall consists from inside to outside 6 mm thick plywood, 1 to 5 mm thick common brick, and 6 mm thick cement plaster. Okay, let's try to draw the multi-layered wall. Okay, so we have a wall here. Okay, let's make it quite big. Okay, and then we have 6 mm thick plywood, 1 to 5 mm thick common brick, 6 mm cement plaster. Okay, so we should have kind of 6 mm here, 6 mm here, and also 1 to 5. Okay, so this one 6 mm of plywood. Okay, now we have 1 to 5 mm of brick, and then we have 6 mm cement plaster. Okay, so next, the values of internal and external surface conductance, which is HI and also HO, okay, for the wall are 8.3 and 34.4. So here at the one, okay, let's put this as HO, which is 34.4, and this one is HI, which is 8.3. Okay, find the overall heat transfer coefficient of the wall. Okay, so here, first of all, we will use, okay, because we want to determine the U, so we will use this equation, this one. Okay, 1 over U is equals to this one, 1 over HI plus delta X over KW plus 1 over HO. Okay, and HI and also HO, we already know the value. Okay, already stated in the question. And the next thing that we want to find is this one, the middle part here, delta X over KW. So delta X here, we have 3 delta X. Okay, the thickness, we have 3, 6 mm, 1 to 5, and also 6 mm. So means that to calculate the value of U, okay, so 1 over U there, okay, so we will have 1 over HI plus delta X1 KW1 plus delta X2 over KW2 plus delta X3 over KW3 plus 1 over HO. Okay, so this is how you can calculate the value of this U here when we have a multiple layered wall, like this. Okay, so you just add everything. Okay, add the thickness over the resistance here. Okay, this one. Okay, so we have plywood, we have brick, and we have cement plaster. So let's check the table to determine the value of this KW here. Okay, so for plywood, the conductivity here is 0.1. Okay, and next we have common brick, we have 0.77, and then the last one is cement plaster. So cement plaster, this one, plaster cement here is 8.65. Okay, so we must use this one. Okay, we must use each value here for this one, KW. So plywood here, this one is 0.1, and brick here is 0.77, cement plaster is 8.65. Okay, so let's look at the solution. Okay, this one. Okay, So when we want to calculate 1 over u here, okay, so the thickness must be in meter. Okay, you must change from millimeter to meter. Okay, so this one is for plywood, this one is for brick, and this one is for cement plaster. Okay, this one is 1 over HI, this one is 1 over HO. You will get this number 0.3726. And after we do 1 over this number, we can get the value of U is 2.684. Okay, watt per meter square Kelvin. Okay. So this is how you calculate this one. Heat transfer coefficient of this wall here when we have a multi-layered wall. Okay, the next one. What is the value of U if a 20 mm thick EPS board is added? Okay, so because we want to add another material, okay, like this, okay, for example, we add EPS board inside. Let's say, so this one is EPS board. Okay, and the thickness is what? 20 mm. 20 mm. Okay. So we must know what is the thermal conductivity of the EPS board. So let's check the table again. Okay, this one, so EPS. This one, EPS is 0.037. Okay, the value of kW here 0.037. So this one will be kW 0.037. Okay, so when we want to add something to the wall here, so means that we just add plus another delta x 4 lah. Okay. 4 over kW 4. Okay, means that we want to add another material which is EBS board. Okay, just add in this equation here. So if we calculate, we can get the value, this one. This one, okay, so we add another part which is this one. And we can get the value is 0.9132. And then we do 1 over this value. Then we can get the value of U here is 1.095. Okay. So let's compare these two numbers here. This one is much higher than this one. Okay. So because we are adding an insulating materials, okay, on this wall here or in this wall here, so means that we want to prevent the heat, okay, from traveling from outside to inside or from inside to outside. Okay, based on the temperature difference. Okay. So means that if we have insulating materials, means that it is much harder for the heat to be transferred in or out to in. Okay, either one. Okay, so means that the lower value of U represents a much more lower value of Q. Okay, that's it. Okay, that is the conclusion here. Okay. So, a lower value of U means that we will prevent a much more heat transfer rate. Okay. So, actually that's all for our lecture for aircon here. Okay. So, hopefully we will see you again. Okay, maybe in the next video or in the other video. So, please check my channel for other videos. Okay. So, see you again in the near future. Bye bye.